All right, welcome back to The Explainer. Today we're diving into something, well, pretty ambitious. It's a thought experiment from a German text called Ursprung und Einheit des Kosmos, which basically means origin and unity of the cosmos. And the idea? Oh, just to describe everything from the Big Bang all the way down to quantum mechanics, using just one single geometric shape. No big deal, right?
So the author kicks things off with this incredible line. It really sets the stage for something massive. We're not just talking about physics equations here. This is about our place in it all. Starting from the literal beginning of existence and drawing a line straight to, well, to us right now. So how on earth do you even begin to do that? Okay, so the core idea, in its goal at least, is kind of breathtakingly simple. The whole point is to build one single geometric shape that can hold two totally different worlds. You've got the huge, expanding universe out there, and then you've got the super weird, probabilistic world of quantum particles. And this model tries to, well, literally draw a picture that contains both, a picture of all of reality. So let's start building this thing. The whole process kicks off at the biggest scale you can possibly imagine, the entire cosmos. Step one is all about drawing the outer edge, the boundary of our whole model. So, to get started, we need a solid anchor point in the real world, right? You can't just make it all up. So the model grabs a number straight from standard physics, the age of our universe. We're talking about 13.6 billion years. And everything in this geometric construction is built on top of that one single well-known fact. Okay, so now we have this huge chunk of time. Next, we've got to turn it into a distance. And how do you do that? Well, you use the ultimate speed limit of the universe, the speed of light. You multiply the two, and what you get is a really profound number. It's the absolute maximum distance that light could have possibly traveled since the Big Bang. And that distance, that's going to be our cosmic radius. So picture this with me. We're going to draw that line, right? The one that's 13.6 billion light years long. It starts at a single point, the origin. The text then says to imagine two observers, one sitting right there at the center and another one way out at the very tip of that line. Now here's the cool part. You take that whole line and you spin it. You rotate it all the way around the center point. And when you do that, you trace out this absolutely massive circle. And this giant circle gets a special name in the text. It's called the Einheitskreis, which translates to the unity circle. Think of it like the main frame of reference for everything that comes next. It's sort of like the equator of the cosmos. It's what defines the absolute boundary of the universe we can see. Okay, so we've got our cosmic boundary, our giant circle. Now for step two. And what the model does next is, well, it does the exact same thing all over again. But this time, instead of going big, we're going to go to the smallest scale you can possibly imagine. We're going to build a second circle, but this one's for the quantum world. The procedure is exactly the same. We start a line from that very same origin point, but instead of letting that line stretch out for billions of years, we stop it. We stop it after just 1 unit of Planck time has passed. That's the smallest possible tick of a clock that physics allows. So the length of this super, super tiny line is 1 Planck length. And then you guessed it, just like before, we rotate that tiny line to trace out a second, infinitesimally small circle. And here's the thing, this isn't just some abstract geometric game. The source makes a point to say that this tiny little circle, it actually corresponds to something real in quantum mechanics. It's the equator of what's called a Bloch sphere. And that's a tool physicists literally use to visualize the state of a quantum bit, or a qubit. So, you see, the model is making a direct connection from its geometry to actual working physics. All right, now for the really crucial part. This is where it all comes together. We have our two circles, right? One is cosmically huge, one is quantumly tiny. They were built using the exact same logic, but they represent two totally different realities. So, what's next? You gotta merge them. And you can really see the difference here. On one hand, you've got a timeline of billions of years, a scale measured in light years. And on the other, the absolute smallest flicker of time and space you can even think about. But here's the incredible claim the author is making, that these two completely different realms, they're just two sides of the same coin.
They were both created by the exact same geometric move. So by laying that tiny quantum circle right on top of the giant cosmic one, the author says, poof, a single unified geometrisches object, a geometric object, is created. And this one object now holds everything. Within its very structure, you have the grand expansion of space and the weird superposition of quantum states, all in one place. Okay, so we've built it. We have this object that holds everything. Now what? What's the point? Because a model isn't just a pretty shape, right? It needs to have rules. It has to do something. And this is exactly where the whole project takes a turn, away from just physics and geometry and into the world of philosophy. So the author goes on to propose that this entire system, this object that we just built containing all of reality, it runs on 3 and only 3 fundamental laws. And here they are. First, you have Bewegung, which is German for movement. Second, Denken, which is thinking. And third, Zeit, or time. So, movement, thinking, time. See anything kind of weird about that order? Yeah, that sequence feels a little off, doesn't it? You'd think it would be movement, time, and then thinking. But putting thinking right in the middle, that's totally intentional. It's a deliberate choice by the author to make us, the people observing, the people thinking about it, stop and consider our own role in all this. The point is, in this model, we're not just outside spectators. The very act of us thinking about the universe is a fundamental part of how the universe works. And the author explains why he does this. He warns that if you just have a cold, hard, purely scientific description of reality, it can lead to something he calls cultural disharmony, or cultural disharmony. It's that feeling of being disconnected or alienated from the very cosmos that we live in. And this, right here, this reveals the true goal of this whole thing. This geometric object, it's not just a model that you're supposed to go out and test in a lab. It's presented more as a process, a tool that's meant to get you to completely rethink and recompose your view of the world from the ground up in a way that puts the observer, physics, and philosophy all together from the very start. Which leaves us with one last, pretty provocative question to chew on. If the cosmos, according to this model, is built on rules of movement and time, but also thought, what does that imply about the role of the thinker, about your role? It suggests that consciousness isn't just some random accident that happened to pop up. It suggests that it's a fundamental, central piece of the very fabric of reality. Pretty wild stuff to think about.